find probability of x being greater than or equal to 2y. Now this part is tricky. Now let me draw you a picture now. Okay, so let me erase everything here. So I have again my two-dimensional base of the distribution. Okay, so let me turn in black. Okay, so I have two-dimensional distribution here. So I have x here and I have y here. Okay, now you see my values, my random variables are taking values which are greater than or equal to 1. So I have 1 here and 1 here. Okay, so I am just going to write it for once. Okay, I'm just going to write it for once and erase that. So my random variables are taking values in that region, right? Only in that region. So y can take values which are greater than 1, and x can take values which are greater than 1. So I'm just going to erase these parts. So this is my region. Now the question asks me this: what is the probability of x being greater than or equal to 2y? X is supposed to be greater than or equal to 2y. So let me draw the line of the function where x is equal to 2y. So x is equal to 2y. For example, when x is 0, y is going to be 0. And when x is equal to 2, y is going to be equal to 1. Okay? So if y is equal to 1, x is equal to 2. So that line is that line, right? So it is somehow something like this. Okay. So that line is that line. This line is the line of x being equal to 2y. Okay. Now the question says x is going to be less than, or I'm sorry, x is going to be greater than or equal to 2y. So my friends, if you are careful enough, you will realize that x is greater than or equal to y in that region. So that is the region that I am going to integrate. Okay. So basically, I am going to calculate the volume under the joint probability density function in that region. So how am I supposed to calculate that integral? So how am I going to write the boundary of these integrals? So again, I am going to run a double integral of the joint density function fxy. I am not going to write the variables in that function. So because you know that function is going to be automatically written here. So let's just say I am going to integrate the inner integral with respect to x and the outer integral with respect to y. Now in that region, the least and the maximum possible value of y can take is from 1 to y, right? So in this shaded region, because this shaded region is unbounded, it continues until infinity, y can take any value from 1 to infinity. So the boundaries of the outer integral is this. Now let's just say we have a fixed value of y. So we have a fixed value of y like that. Okay. So let me use a straighter line. So for a fixed value of y, x is taking which values? X is taking which values? Now x is supposed to be greater than 2y. So here I have 2y. So x is taking values from 2y to infinity, right? Because x is greater than or equal to 2y. So the lower bound of the second integral here is going to be 2y, and upper bound is going to be infinity. If you calculate that integral, you are going to calculate the probability of x being less than or equal to 2y. Okay, 2y. Now, how about if you do the other way around? So let me go back to black again. Let's just say you are integrating the joint PDF fxy. The inner integral operator belongs to y and the outer integral operator belongs to x. Okay. Now, let's see in that shaded region, the least possible value that x can take is 2. Be careful, not 1. In that shaded region, the least possible value that x can take is 2, and the maximum possible value that it can take is infinity. Now, for a given x value, any given x value, what are the possible values that y can take? The possible values that y can take is from 1 here to x over 2, right? So from 1 to x over 2, because that function is equal to what? X is equal to 2y. So that value should be x over 2. So from 1, the y is taking values from 1 to x over 2. So in both ways, you can calculate that probability. And here in part C, it is using that way. So the outer integral belongs to x, and x is changing from 2 to infinity. And the inner integral, it belongs to y. And for a given x value, y is changing from 1 to x over 2. Okay? And in that way, as you integrate x from 2 to x, you are integrating y from here to the upper part of this line. And you are basically, when you integrate that joint PDF, you are calculating the total volume under the function in the third dimension in this region. So you are basically calculating the total volume under the function in the third dimension. So that function is here, okay? And the drawing I am drawing here, so that drawing that I draw here is what? It is basically the base, only the base of that region, okay?